Last day of new material in Chapter 5, and we've taken derivatives of all kinds of different functions. So this time what we're going to do is we're going to integrate an exponential function that's not e to the x. So other than, so we have different bases here. So this integral, if we want to set it up, this is one that I might actually give, I'll give the formula 1 over natural log of a times a to the u plus c. So if I've got that, the only difference between integrating that function is I have to put 1 over natural log of the base in it. And I can go through the proof if you'd like. It's actually not the most pleasant thing, but we can go ahead and we can do it. So what I'm going to do is I'm going to start with y equals a to the u. I'm going to make some more space here because we're going to need it. So I'm going to start with y equals a to the u. And then I'm going to do something that's going to look a little bit strange. I'm going to introduce an e and a natural log. So I'm going to say this y is now the same thing as e raised to the natural log of a to the u. That's in the problem. Remember, e and natural log cancel each other out. So now, if that's the case, now I can rewrite this function. So if I rewrite this function, what I've got going here is I've got y is the same thing as e to the u times natural log of a power. Well, now if I go to integrate this thing, e to the u times natural log of a power du. Well, now I've got myself set up to do what I would call, it would normally call a u substitution. But I'm not going to do a u substitution here because I'd be introducing, basically my substitution would be, I'm going to say m here just for kicks, is going to be u natural log of a. Now can I rewrite that integral so that it has all m's and no u's in it anymore? So what's dm over du? Well, let's see, that's natural log of a times, wait a minute, derivative of u would be 1. So my dm that I need to put into the problem would be natural log of a times du. So the du that's in the problem would be 1 over the natural log of a times dm. So now if you go to rewrite this integral that we have up here, we've got integral of e. What's my new power? Well, my new power is going to be m dm. Whoops, let's make that look like an m. So as I'm rewriting it, e to the m dm, well, we know how to integrate that. So if I integrate that, that's going to be e to the m plus c. Well, what's m? M would be this u natural log of a. So e to the u natural log of a power. Sorry, I kind of forgot something really, really important. I forgot the 1 over natural log of a in front of this thing, which is kind of a big deal, which is what we're trying to prove in the first place. So here's my 1 over natural log of a, and here's my 1 over natural log of a. Well, now, if you reverse the power, make the u be the exponent, what you end up with is 1 over natural log of a times a to the u plus my c. So I said the proof was a little bit involved, and it is. So this might even be one that you find a little bit easier to look at and go, okay, well, I got to do, if it's a base other than e, so a is still a number. It's not e to the u. E to the u is my favorite. It's a to the u. So what am I going to have to do? I'm going to have to throw in, and I'm going to have to throw something in order to be able to make that thing work. So in order to make that thing work, I'm going to have to do, well, let's try it out and see what happens. So I'm going to say u is negative x squared, so du negative 2x dx. So the x dx that's in the problem, negative 1/2 multiplied by du. So I'm going to have to throw in a negative 1/2. And now what am I integrating? Well, let's see. I'm integrating 5 to the u power. Pardon me. Pardon me. Du. So now, integrate that thing. Well, according to the rule up there, I'm going to keep the negative 1/2. I'm going to throw in a 1 over natural log of 5. And I'm also going to throw in that 5 to the u plus my c. Clean it all up. What's it going to look like? Negative 1 over 2 times the natural log of 5 times 5 to the negative x squared plus my c. And I could move my 5 to the negative x squared down to the bottom if I wanted to clean up my negative exponent.